Hello. In this video, we're going to talk about scientific notation. Specifically, what do we consider to be scientific notation, and just as importantly, why we do it, and how do we go between how we normally write numbers and scientific notation. Okay. And through this, I want to look at some numbers. Okay, so let's first look at this, okay, over here. And let me get my pointer together. Okay. Over here, I have 6022, and then there's like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20 zeros in there. When I have that many zeros, I'm going to lose count. It actually makes it very hard for me to understand. We know that big numbers are hard to visualize, and this is a number that does show up. This is the number of hydrogen atoms in 1 gram of hydrogen gas. Okay? Another example over here, taking hydrogen again, is the radius of the hydrogen atom. And as you may know, the atom is very small. This is 0.10 zeros and then a 5. So the problem we're running into now over here again is that it's very easy to lose count. And this is not the smallest number we have over there. It also reaches beyond science, that we may have big or small numbers. Okay? For example, our national debt is 33.17 trillion. So 3317, and you can see here we've got 10 zeros. In each of these cases, you can see that if we have very big or very small numbers, it gets hard to visualize what the number should be if we don't do something not so common. This is why we need scientific notation. Okay? So in scientific notation, what we are doing over here is that we're expressing numbers in this way. You have something times 10 to the something else. Okay? So over here, the numbers, let's give it some names. Over here, A over here is the coefficient. And as you saw, we want to make our numbers close to 1, not too big, not too small. And so by convention, we make this number between 1 to 9.9 recurring. So between 1 and 10. Not 10, but anything below 10. Okay, 1 point something, 9 point something. Okay, and it can be negative. Okay, times 10 to the, and here's an exponent, which would be a whole number. This can be positive or negative. Okay? And you may need to recall that if I put an exponent over here, I mean that I'm multiplying whatever is here so many times. So for example, 10 to the 3 over here is shorthand for 10 times 10 times 10. I multiplied 10 3 times. And so that would be 1,000 over here. The other thing to remember is that if we have a negative exponent, for instance, 10 to the minus 2, okay, that minus means that we are dividing 1 by whatever number is left without the minus. So here, remember, minus goes under. So this will be 1 over 10 to the 2. So that's 1 over 100. 100. Or if I use decimal notation, it's 0.01. Okay? So what we want to do next is to look at how we can go between decimal notation and other notation and scientific notation. So over here, the key is we want to move this decimal point, right? move decimal point so that the number becomes between 1 and 10. Reminder, you want it between 1 and 10. So, to do this, I have to move it to the left by 1 spot, which means I had to divide it by 10. So I need to multiply it back by 10 to get the same number. So I get 3.246 times 10. Now, it's just 10. So I only multiply itself by itself once, so that's 10 to the 1 over here. Conversely, let's look at this one, 0.004875. Now let's look at how many times I need to move this. 1, 2, 3. I had to move this decimal point 3 places to the right. I had to multiply that number by 1,000. So if I move the decimal point to the right, I have negative exponents. So here I have 4.875 times, and I just moved that decimal point 3 times. So that's 10 to the minus 3. Okay, so that's converting it to scientific notation. Let's look at the other way around. Here, we now want to express numbers in decimal form. Okay, and to do this, I need to multiply that. And if I'm having a positive one, I need to move that decimal point to the right. So I need to make that number bigger, right? 1, 2, 3. So I have 2,351. Now over here I have a negative number, 3.51 times 10 to the minus 4. So if I do that, I have to move this over here now. 1, 2, 3, 4 times to the left. Because I have 4 here. So 1, 2, 3, 4. So I end up with 0.000351 as my number. Note, be careful here. Just because you have 10 to the minus 4 doesn't mean that you will have 4 zeros after the decimal point. It's only 3. Okay?